Hello Year 11, it's Miss Bailey here. Please have your worksheet ready to be completing it as we work through this video. So for your Do Now activity, looking at the graphs that we looked at the end of last lesson, can you identify 3 factors which might be affecting our rate of reaction? So remember that we can use the gradients of our graph to be an indicator of our rate of reaction. So what factors do we think are affecting the rate? Pause the video whilst you have a go at this. In this lesson we're going to be looking at collision theory, and in order to illustrate this I'm going to show you a simulation. What we should be able to see here is some blue and orange particles that are going to be reacting together. So I'm going to press play, and so when you see a flash, this is a reaction happening, and so our reactants are the black particles. But what you should be noticing is that actually when the blue and orange particles collide with each other, they don't always result in a reaction. So collision theory stems from the idea that we need collisions in order for a reaction to take place. But it's also showing us that there's more to it than just them colliding together, because the collisions don't always result in a reaction. So reactions can happen when particles collide. So the reactant particles must collide, but the other part of this is that there must be sufficient energy in order for the reaction to happen, and that's our activation energy. And we've come across activation energy before as being the minimum energy that we need for a reaction to happen. And we've looked at that when we've done our reaction profiles, and we've seen that for our reaction to happen, we must overcome that barrier for the reaction. So thinking about how we can increase our rate of reaction, we're going to need to be thinking about both the collisions and our activation energy. So the way in which we can increase them is by having more frequent collisions and more collisions with sufficient energy to react. Make some notes on what we've just been discussing about collision theory, what reactions need in order for them to happen, and how we can increase those chances of a reaction taking place. So pause the video whilst you have a go at that. So how could we increase the chance of reaction? So thinking about those multiple choice graphs that we looked at the starter, there are 5 ways in which we can increase our chance of reactions. Some of those were present in those graphs. So the 5 things that we can change is our concentration if we're dealing with solutions, pressure if we're dealing with gases, but then also our temperature, surface area, and our use of a catalyst. Okay, so we're going to have a look at how temperature can affect our rate of reaction. So we're going to go at 40 degrees and see how long it takes us to make 50% of our product, and then we will repeat it at a higher temperature. So that took 12.7 seconds roughly, and so then let's restart it but at 80 degrees. So we've increased the temperature. So this time that took 6.6 seconds. So by increasing the temperature, we reduced the time it took for that reaction to happen. So if you were watching the particles, you can see that they're moving a lot faster, and therefore they're having more collisions with each other. But also at higher temperatures, they have a higher amount of energy, and therefore they will have overcome that activation energy barrier. So let's now look at how surface area can affect our rate of reaction. So keeping our temperature the same, so we will again time it for 50%. Okay, so this took 40.4 seconds, and so we were doing this at a temperature of 80 degrees, so this is a comparison to the 6.6 seconds that it took when our orange particles were separate and free to move around themselves. So by having all the particles in a massive lump, this shows us that it took a lot longer. And that's because we have reduced the number of active sites that reactions can happen, because we have reduced that overall surface area. So you can see the orange being a bit of a long Pac-Man shape, whereas with our blue particles, which is what our orange particles were like in our previous examples, we've got the entire surface area of the sphere. There are lots of orange particles here which are not exposed and not able to have that reaction, and that's why it's slowing down a lot. With a catalyst, we lower the activation energy, and that means that our particles, more of those particles are overcoming that energy barrier required for our reaction to take place. So just to summarise the different factors and how they affect them. So both concentration and pressure affect our rate in the same way. So this box here, we are increasing our concentration, so more particles in that volume, whereas by reducing our volume here and forcing those particles closer together by increasing the pressure, we again have more particles in a given volume. And so in each of those cases, we're having more frequent collisions, and if we're having an increased frequency of collisions, then we're increasing that chance of a reaction happening. Our temperature one we have looked at with the simulation, but we're giving those particles more energy, and so they're having collisions that have enough energy in order for the reaction to happen, so more particles overcoming that activation energy barrier. But also the particles are moving more, and so we're also having more frequent collisions. And as we just said, increasing the frequency of those collisions increases the chance of a reaction happening. Increasing surface area, so we saw the effect of that in the simulation. So by having more sites for a reaction to take place, that means that there are more frequent collisions, and therefore increasing the chance of the reaction being successful. And with our catalyst, by providing an alternative pathway that has a lower activation energy, this means that our collisions are happening with more sufficient energy, and therefore increasing the chance of that reaction being successful. So what I'd like you to do is, on your worksheet, there are sections to each of these 5 factors, is can you explain why each of those factors increase the rate of reaction? Thank you all for watching, and see you next time.